So I am going to talk, about the journey India has taken to walk step by step and finally reach some summit. In the summit, I include Moon, Mars, etc. And this is, I cannot tell that this is, see, generally all of us like to talk about our work. Actually, we do it with a little, actually my work. So, but today it is not my work, but it is definitely our work for sure. And it is about something which I am not going to go into very detail of some intricate, physics, chemistry, geology or maths, but give you a flavor of what India did to go into a new area which we call planetary exploration. So we have explored quite a lot, geosurface, we have explored the ocean, and so we have explored the atmosphere, so we need to go a little bit more, and the closest is Moon. Then we have gone to Mars, and there are hopes that we may try to make it to Venus. So that's what you thought, what I am fishing, why a fish should be here. Okay, I said fishing village, but that is how things started. You see, Indian space research has started because of the foresightedness of Professor Vikram Sarabhai. See, many people know Gujarat for business, but there are some very outstanding people in each field. Whether you call, science, art, culture to architecture, everywhere they are very good people, but they can be counted. Okay, the other people are very busy with business. But what is interesting that Professor Vikram Sarabhai, he was also a part of business only, but he did his PhD partly in India, partly in UK on cosmic rays, and then he was also doing the business part also of his family, and then he started physical research laboratory, I think with 2 people and 1 small room in a college. Okay, the starting point. And then of course it is now a big laboratory, but his vision is something which many of us do not have, and at least I do not have, how to think what may happen, say 30 years from now. We are nowadays happy if we can tell what will happen to us within this year, at the end of this year. So why I am telling you this, because you see, this is how he started. So he thought that we should do space research, and then what he wanted to do, he wanted to study atmospheric phenomena, above the, what we call, not the equator, geomagnetic equator. Normal geographic equator is different from geomagnetic. So to see there are certain things happens there, and if that can be studied, and it happens up in the atmosphere, and you have to send something, balloon or rocket or something to study it. And so he wanted to consider launching rockets for studying upper atmosphere, 1961. I mean, so this is much ahead of time in a sense, people will feel. Okay? So what he did, he identified a fishing hamlet, okay, village, Thumba, along the Arabian Ocean. It is here, okay, somewhere there, where he wants to set up this rocket launching center. Reason is very clear, geomagnetic equator goes to that point, and of course you need an ocean. The rocket goes up, you don't know where it will fall. So sometime, okay. And then the people who were living there, he talked to them. There was a bishop, Charles was there, he talked to them and told them that he will want to set up a space center, then he will give all the alternative needed to shift them and everything, and the bishop finally agreed. And so he said new residence will be made for him, bishop and fishermen, new school will be made, a new church will be built. And you see a church here, that was the old church. Okay, and then as the way he does it, they have agreed, and he never broke down this church. It is still there as a space museum, and initially it worked as the scientist office to start with. So now first rocket launch, you see, that was 1961, and in 63 he took up, Kalam was his first inductee for this work, Abdul Kalam, APJ Abdul Kalam. And then once he got this idea, but what we will put in the rocket? We need something to study the atmosphere, and we are still not up to it. So he had a very good French friend, very well-known scientist, he is still alive. And then he convinced him that he can put his payload, as we call it, instrument, and we can go up together. So the first, our space adventure was also in international cooperation. Okay, so then we had this French instrument, and you see, look at those days, how things move. Okay, and even on that time he was telling, there are some who questions the relevance of space activities in a developing nation, because we have nothing to eat and why you want to go to space. But he said, if we are to play a meaningful role nationally and in committee of nation, we must be second to none in the application of advanced technologies to real problem of man and society. He is not talking about doing science as yet, although that is his part of his job, but he said serve science and society. So this was his main aim, and you see the beginning stages, how it is. Okay, in bicycle, rocket parts are being carried away to check somewhere in another lab. Okay, that is how he started. And that rocket went up and did some measurement also. But the others is very interesting. Then now we can make some satellite, okay, not very big but small satellite. Now you want to test the satellite, see where it goes, okay, in a bullock cart. Now you say, why a bullock cart? See, we need an environment where there is no magnetic interference, okay. A wooden wheel without that metal, and that is the best non-magnetic thing where you can take it and check everything. You see, I mean, why I am telling this, it is interesting to see. Nowadays, sorry, there are a lot of young people, they first want everything should be ready-made and be that, then I will put it together. But those are the days, okay. And then, you see, Sarabhai passed away in 73. He saw the rocket flight, but not others. But by that time, Professor Yuva Rao, who was also there, he was asked to make a satellite. So a satellite was made. It's so heavy that forget about us. But finally, Russia said, okay, we'll take it up. We'll send it. We were very good friends there. And then 360 kg, it is huge, because we had that kind of, So then, it went up with an X-ray astronomy payload, then solar physics payload, okay, aeronomy payload, all three. But it survived there only for 4 days, and it collected a lot of data in X-ray astronomy. Paper is also written, but the others it didn't, okay, because of it got heated up and certain anomaly has happened. So this is the beginning, okay. Now I will cut short another 40 years. So what we have today, okay. Again the same thing, we must be second to none because if we don't develop technology ourselves, there is no use. So we now have launch 2, 3 launch vehicle. Now all of them work regularly. In between, some of them, GSLV, it goes up 2, 3 missions were not good. Now everything, but again, application and human resource expertise, larger user base, that satellite, in our own satellite for telecommunication, industry, space commerce, many things they were looking at. But most important is remote sensing and telecoms communication. Remote sensing and communication is the two most important thing that ISRO is giving to India. And India doesn't have to look for anybody else today to look for any data or anything anywhere in the globe if we want. Okay, so realization of the vision, it took some time, but you see, now we have all these things. So now we have 2 launch pads, one is here, one is up there. 2 of them are there. And then, yes, see, this is one and this is another. We have PSLV is our workhorse, we call it. It never fails now, okay. GSLV we have problem, but last 3 missions were all successful, so now we have competence, and this is under preparation. We need heavier one if you want to go further out and things like that. And you see, it is all indigenous effort, okay. So, and now when we are going to moon, we realize that we do not have any antenna that can send it there and get it back. So in 3 years time, 32-meter antenna has been made, and it is working, and it is world class. So you see, there is one good thing about ISRO. It is still like a family, although it has 5 centers, unlike many other places, because they know that if they don't talk to each other, things will not go up, and there is a spirit of that is there. Now, how much we have done so far? Okay, this has to be application-driven, self-reliant program. That is very important. Okay, and then remote sensing and communication centralized, and this is very important in ISRO. It has ties with industry for realization of mission hardware. We make only ISRO makes only the critical things which they cannot outsource to something. But otherwise, whether you call Godrej or anybody, L&T, anybody you talk of, they are all doing business with ISRO, and that is why we can sell, make a mission so cheap. If you consider outside, ours is peanuts. Because all these business people, industry, they feel proud that they are with ISRO. So they also charge the minimal probably profit they need to survive, and so our that is quite good. And you see, 1995 to 2005, we could send up only 20. That is almost 10 years. Okay, 95, 05, yes, 10 years. So now, and then you see, we have 20 launch vehicle in 95 to 2005, that's about 11 years, and human resource we have about 10,000 strong, our own, and others are working in other areas. Okay, now you see, that is 10 years, now 2006, in 9 years we have 26 launches. Okay, in last 9 years, and this is just to give you a feeling. This is the open up, that is satellite is up there. This is these 2 things will close. That is the rocket which will take you up, and then current capability 6+ launches in a year. So we can do it. Everything is happening. Okay, now where do we want to go? Okay, by default, moon was the first mission closest to us. So moon, then we have gone there. Mars, we have gone there. Chandrayaan 2 almost ready, couple of years maybe we will go up. It will have lander, rover, everything. And then we want to go to Venus also if possible, but Mars again for sure sometime. Whether it will be Mars or Venus, it will depend upon our technical capability, because what happens, Venus is a very difficult. I don't know why people choose Venus as the phrase amongst us to talk about beautiful things. Okay, so beautiful beauty is Venus. I mean, but it is one of the most difficult places to go. Nothing can go down. I mean, it will burn up in about going about 100 kilometers or so through its atmosphere, 100 or 200. Survival is a big problem. But their technology is coming. People are going, but not very successful. But we would like to take this as a challenge. This is probably for the next decade. Not currently. It may not come out well. Okay, then it is not only planetary exploration. ISRO has started another science exploration also. Most important is astronomy satellite. It has gone up in 2015. But again, it took almost 12 years to go. Because always in this instrument, you have to make it everything yourself. Some problem happens, then once it happens, you have to take up everything, put it back. But it is giving excellent result, and at an international level, and all the instrument from ultraviolet to gamma ray, everything is working properly, and already a lot of good science is coming. Then we want to go and look at the sun all the time, because that sun suddenly gets angry, throws out some flares or sometime other stuff which affects the terrestrial environment. So this coronagraph, but if something is orbiting, we have the sun and everything is orbiting around it. But if you can put one of the satellite in one particular point, there are 4 or 5 points, it is called Lagrangian points. If you put here, the gravity pull from all sides is almost equal, so it will just keep on oscillating at that point. So you are stuck there, you are looking sun all the time. If anything happens in the sun, we will know it immediately. And so we'll get from sun to here also, it takes time to come, anything to come, like some coronal ejection or something. So we'll have enough time. So that is under making, and one more astroset will go sometime or other, and we'll go there. This is one thing that we have not been able to do well is that space weather and sun earth relationship. For this you don't have to go to sun, you have to just go up and monitor. Okay, here we are not yet because we are not getting a good kind of model or something like that, which if you put up will satisfy everybody's need. I mean, whatever we need to know. So, but it is under discussion because it is for national need. Okay, so let me go to planetary bodies. Okay, you see, something about planning of ISRO, that is very important because it is very good. You see, in 1999 in New Delhi, ISRO told that ISRO can undertake a mission to moon, blah 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 blah, so much. If everything works well, it could be a reality in 2008. Okay, and with lot of effort in 2003 only we got the approval at the end, and 2008 we went. See, in 1998, and I was not even born in moon mission by that time. I was a reluctant entrant around 2001 or so, because anyway, or whatever it is, but I enjoyed it. Okay, so now we have to go to moon. So what we need to go to moon? We need a launch vehicle so that it will put the spacecraft in orbit, and it will keep on doing like that. Then again it will come to Earth, get little more energy, and after this, if you can push it a little more, it will go towards moon. Okay, spacecraft has gone towards moon, but you have to be very correct in this orbit, otherwise you will miss it. So, but we are good at it because we have gone to moon. Then Earth moon communication unit, I showed you that huge antenna. Okay, then next, maintaining lunar orbit. It is very difficult because moon has also highs and lows. So your spacecraft will not just go nicely like this. It will also go up and down, and sometimes because of that, it may even tumble or lose its balance. This can happen, and it actually happened to us after about 9 months. No, 10.5 months, 10.5 months. Okay, it happened to Chandrayaan-1 also, but that is. And then you see, this is need to be self-reliant in all the technologies. It's a difficult task. Has to start from scratch and run from mistakes and failures. Failure, so like we have failure is the pillar of success, as long as the pillar doesn't become too heavy. So key to success is, here science doesn't get credit. Key to success is sound engineering, banked by analytical analysis for all this orbit and everything. And once we are up there, then can only scientists come into picture. Otherwise, they are the king, because the people who are working on it. So you see, moon now, what we have roughly learned, we have gone to moon earlier. I started my life with analyzing moon sample. So what is the main thing we say? That it is a major conclusion is that, you see, origin, impact on Earth. Something came and a huge impact took place on Earth. It removed some material, put on in the orbit, and finally it became the moon. So why? Because there is a lot of chemical similarity between moon and Earth in many ways, and you can give many reasons why it is. I am not going to give. You have to believe me today, okay? So that it has happened. Global magma ocean. Well, you see, it like moon was at one point, at the beginning, was covered completely by liquid. I don't know this word like magma and other thing very strongly, so I am saying liquid, okay, covered by liquid. How we know it? Okay, look at the picture of the moon. Okay, this is the picture of the moon. Okay, front side. We don't see the back side. Now this is the back side. You see, everything is almost white except some patches are black because something hit there. So you make a crater, huge crater. That back side, there is a huge crater. Okay, on front side there is a lot of, these are all craters. And we landed somewhere up there. So now the white is, this is nothing but anorthite or feldspar or whatever you want to say. Anorthite is the class. So anorthite reflects much more light than pyroxene or olivine. Okay, so it is reflecting surface. So this is anorthite. And then how anorthite is the lowest density amongst all the mineral, it is there. So if moon got molten, Then what will happen? Lighter will come to the top, it will sit there. So anorthite was the first layer. Then you will have pyroxene, olivine and all those, and mixer also as you go down. Okay. So it is a fact that it was global magma also, it was molten. And then moon is bone dry. So in lunar sample, Apollo time, many work was done. Can you find water? Then somebody say, I find water. Then somebody will say it is a mistake. And yes, sometimes it is mistake because contamination is very easy. So now, then at that time itself, there was a, after this mission, in 1994, there was a radar mission. Radar can go below the surface also and can give you some idea. So that radar, when it was put in the polar region into some holes, polar holes, they found that the signal coming back looks like as if there may be something like water, but it was not, completely proven, because they got something, they got a return. That doesn't prove it. You have to do little more than that. So nobody believed that whether it is right or wrong. So you have to, because that the single radar and reflection cannot give you the whole story. It can be something else also. But this is in 1994 somebody was trying. That is by radar. Okay. Now coming to moon mission, we tried to do everything possible, and then we were not good boys in eye of the globe at that time, because in 1999 we have exploded a bomb. Okay. And because of that, many people will not give high-end instrument which we needed for looking at all these things. So suppose you have only an old box camera, you cannot do what you do with even your cell phone today. It's a high-end product. Nobody will give us. So then something we can do, but not everything. Then we said that let us make it international. So we talked to people outside. They are very eager to join us. So it has, you see, main people were, of course, ISRO, NASA and European Space Agency. These are all part of NASA and ISRO and JAXA, that Japan also. So we had all these people with us, and then people never came to India earlier for space related stuff, but chairman or chief of NASA has come, signed with us. So we said they have to come here. So they came and signed us. Then chief of European Space Agency also came. So suddenly they felt that we can do it by 2003-04. I mean, they came and signed also, and it was a good thing. You see, when we started, we had only few instruments we could put from ourselves. Then when I was told that, no, we need science, I said this will not work. So then slowly it kept on going up. 2004, 2005, more instrument came. 2006, more came. And 2011 in Kalam said, put even a impactor also, so that we put a mark there. So all this has gone. And then we have to go to the moon. So, okay. So, but before you go to the moon, just to give you a flavor of the size that we have to handle, you can have a look at how somebody makes even those, rocket baskets, which has to finally go up. Let me tell you that in Chandrayaan 1, because of this international participation and everything, we had a very good mission. I mean, there are a lot of new things we have learned, but everybody remembers only that we have found water on moon. I got tired of telling people that we are seeing water molecules on moon, but if people like to say we have found water on moon, water molecule is not water, but still it is okay. So that was like a discovery, and I can tell you also it is not a story, it's a fact that how bias retards in your research. NASA has seen it in 1999 and even earlier ones, okay. And then when we knew that we are seeing something different, I was very critical about it, because I don't want that later it turns out to be wrong. So I said that let us talk to somebody who can confirm what we are seeing, okay. And then what happened, there is an American mission. You see, when you send a satellite, it cannot keep on going all the time. After some time it loses energy. So if it loses energy, what it does, it puts it back to the earth, okay. And when it comes to the earth tries to grab it, but it cannot. It gets an energy and it goes back again with a original speed, okay. You can get it back again. So in that process, okay, now you see what kind of effort it takes to make some of this. And you see that is only one part of those 5 or 6 stuff, okay? And then you can see the people there, okay? So I mean, it's just nice to see. And there are different floors. There are 5 floors. Everybody will work and then put it together. This is our Chandrayaan 1. This is Chandrayaan 1. So, and one thing I realized after seeing this, that one has to be very patient. That, you know, how you do things like that. Nothing you can do here in a rush. Okay, so now that will be closed. Then you see, I will show you, there is one more probably, then I will show you. So this is, you can see the total, this is about, you know, quite a 30 meter or something, quite high, okay, and tall. And finally it looked very good because it's like a railway track. It has to be taken to the, you know, launch site. And then you see it's a railway track kind of stuff. It goes there. And then finally it will sit on that railway track, okay. It looks, you know, quite nice, okay. So now it is waiting for to get launched. This is Chandrayaan 1. Okay, anyway, okay, then what are the, let me come here, highlights of Chandrayaan 1. You see, I was telling water, it is a major discovery, water molecule. Okay, then there are many other things we have found which are new and different. Okay, and but since that water molecule, I will tell you a little more about that, and then maps of moon and all those stuff. You see, I am doing it at a very popular level. So now you see, this is if you have you know, something like sunlight, and if you have some absorber of sunlight, what will happen? For different minerals, you see, this is olivine, plesioke, spinel, pyroxene. If there is pyroxene, it will absorb water at a particular at a particular wavelength. Okay, so you know this wavelength. For H2O, the wavelength is 2600. You know, if you say in angstrom, 2600 is, if there is a water molecule, it will absorb that energy, so you will say see a dip. And now people never thought there is water on moon, so even on all the mission nobody goes above 2600, because that is where your major minerals are almost over. And what we have seen, and this is the vibration, you know, OH or H2O, they will keep on vibrating like that. We have 3 instruments. This is our instrument, which can go only up to about 800 you know, angstrom. Then this is the German instrument, which can go up to about 2000. Okay, this is the US instrument, which can go from here, but it also includes 3000 you know, angstrom. So now water get absorbed around this point. This is about 2800 or so. And earlier mission had this kind of instrument, but they never looked beyond 2500 because there is nothing else there. Water, nobody thought about it. Okay, so moon mineral mapper, this one which were there, so that is, you know, point of contact, and then you see this is how it will look. So now if you talk of, you know, just from a laboratory point of view, anyway, so you can draw like if it is OH, if it is ice, if it is H2O, where the dip will be in absorption. Now this is actual data what we got. So as you see, when you are at latitude 18 degree near equator, this red line, it is all going up. There is nothing like anything absorbing anything. As you go towards the pole and you start at 67, 76, 81. You see, 67 there is a dip, 81 dip. So once we got it, we knew that we are getting water molecule, but I wanted to be sure that, so we want if somebody else can look at it. And I was telling you now, we lose energy, so you have to come back to Earth. One US mission was coming back to Earth to get energy to go back again. And all these missions, they use moon as a calibrator. And calibrator, they have all the wavelength, but they looked only up to 2000, you know, not beyond, you know, feldspar, olivine and pyroxene. They don't look, because those are not there. So again, you know, if you look at the moon, whole moon, total data, you see near the poles only we are seeing this. The blue regions, where we are seeing that there are water molecules. And there is good reason why it should be there, because I must tell you, I read 3 papers. One is 1963, another is in 70s, and one even in 80s. And the 70s paper was written by a professor whom I know well in in California, down there. University, not California, there is down one you go, San Diego, University of San Diego, and very well known person, and he wrote a paper that there should be water on moon because his sun is throwing all this OH and everything. You have SiO2 here. If they talk to each other, O comes and hit a oxygen and try to take a H comes and hit an oxygen, takes a OH, it can happen. And they do a lot of calculation also. But all 3% differs, but they think that it should be there. And that is one reason why we wanted to put it there without telling that it is one of our primary goal. So once this happened, we wanted confirmation that we should now somehow or other get it confirmed by others. That the other mission which we asked it, they went there and they also saw it. Okay, and then of course there was for 2 days there was little tension because they wanted to say that they have seen it first, they want to publish. I said, go to hell. We have seen it and told you to look at it without telling what we are seeing. Now you cannot do that. Finally, of course, all the papers came out in Science together, both the papers, and they agreed that people know that we have got that. But you see, NASA, if you can excite them, they are perfect in certain things. What happened in our observation, most of the areas when dark areas is where this is in lunar polar region. This dark area is holes actually. They are like a trends. So deep trends. So in dark areas we see this signal more than other areas. So NASA when it went the next time, it took a missile, small missile. So they have gone on a spacecraft. This spacecraft, there are two stages here. The first one is like a missile, it will go hit one of these black areas. And the one which is following behind, it has only 2 minutes. It will collect all the data, return to the main spacecraft to bring back to Earth. So their technology is much more advanced than us. So you see, this is the area that was selected, and you see some white patch here. This is where it hit, made the white patch, and whatever came out, they measure all the stuff. And you see, this is, they have started scanning before impact. This is the point of impact. And after impact, you see, this is H2O absorption line. So even if when you hit it, some water came out and there cannot be anything else. So this confirms that water is definitely there, but it is very small. I mean, somebody says, even if you take the whole football field, put the first centimeter out, whatever you may get 1 drop of water or 2 drops of water there. So it is not much, but it is there. And then US, my friends, they are very particular about even doing very finer things. We are happy with water, and they claim that they have found not only water, OH, SO2, H2O, CH3, OH, C2, H4, O2. God help them. Okay, so but it is there. Okay, so now you see, anyway, we got credit from outside world also, but you see, last decade, so many missions are there. We had only one. So we have to be very patient, do something good, so that even if we go 1 in 5 years, we should be able to beat others. And you see, this is, China has about 4 or 5 of them. China is much more advanced than us in technology. They have gone there, and then one fellow loop and came back to Earth. Another one, they went there, they put a rover there. They have already doing all these things. Technology, they are quite good, but for some reason, I don't want to say anything, but in other things, I am not sure whether who does all this work also, nobody knows. Whether they are scientists or who is doing it is very unclear with them. But because so there is not much use talking to them, except you can talk to them in some other place if he is alone, and then we can get some information. So now, which are the other places we want to go? Moon, Mars, Venus, asteroid, comets, everywhere we want to go. So we need lot of activities, technical development. So we are doing something, and then let us hope that we can do it even faster so that we can do more. So this was our plan to start with. Then we will go to Chandrayaan 1, next we will go Chandrayaan 2. Because we had a treaty with Russia. When we were doing Chandrayaan 1, they wanted to come to Chandrayaan 1. No chance. Then I said Chandrayaan 2. Because they said they will give us lander and rover. We want to go and land. So ours is the orbiter, that we know. They will give us lander and rover. So why not go together? But space is very unforgiving. This is 2000, I forgot when it was, 2000, I think, 11, we are talking 2013. Anyway, they were supposed to go, it was a Russia, Europe, Chinese mission, about $2.5 billion. In paper it came, it went up nicely. Then it started orbiting. Then God knows what happened. It says, I am refusing to go further up. And so with such a huge, and finally it fell down in near Australia in the ocean. So because of that, last 6 years, USSR, Russia is only trying to redo everything. And they told us also they cannot go now. So then we said that if you cannot, we have to go somewhere. No? So we said, okay, let us go to Mars. Mars was done like in a record time of less than 3 years. And still, and then we wanted about 35 kilogram of, to instrument. 35 became 30, then it became 25, then it became 20, then it became, when it became 15, I said, I don't want to do any further anything here. So in this 15, still we put some 5 instruments. 2 of them have given very good result. And because sometimes you have to make your weakness the strength. See, we cannot, if this is Mars, we cannot orbit like this because we don't have the energy. Mars will grab us. So we go like this only, okay? And all American people last 10 years, they are only doing this. So they don't know about Martian atmosphere outside, no? Okay? So we have studied Martian atmosphere from 200 kilometer to 800 kilometer out there. So you can talk of, atmosphere, exosphere and all these things are there. So we could characterize, and just recently, in last 4-5 months, 2 paper has come out in GRL and good journals. So, and then we are the first one to point out what is the exosphere, density and other things currently. So even if we have some small instrument or something like that, you can still do. But on pictures, we are quite good. So we have gone to Mars. I mean, I am just showing you some picture. If you say, if I show the Mars there, you will say, okay, they may be from Mars. Because all other things are also from Mars. And these are, carbonate, hematite, opals. Without water, you cannot make it. So there is no doubt that there is or there was water on Mars. And even now on the polar regions, in the, when it is cold, Mars, water ice accumulates. And there was some people say there is traces of methane. Everybody was very excited. Methane means biology, it's organic. So how it can come, so life may be there. And but the general formula now is find water, follow water, if you want to look for life. Because that is what we are. So, and that is also being tried. And then in Mars, it is a technology mission. We are very clear that we cannot do much science because it is squeezed to such a small volume. And and we got the name that we have gone there for the first time and was successful. Okay. And by the Mars time, we have become little more modern also. You will say, why I am saying little more modern. These are the 5 instruments that were put there with only 13.5 kg. And there are quite a few. Color camera has done very good work. Lyman alpha meter, so and so. Ion mass spectrometer, that is doing all the atmospheric work. That is quite good. And the others are, I will say, reasonable. But again, I will not blame anybody because it is not possible to do fine work, compete with others when you get only 2 or 3 kg. Okay. So now I will take a break. You people will listen to some good music and voice. Because my voice is not that good. You see, so there is something, if it works, there is something called, mission challenges for Mars, okay? So, and you will see that ISRO has a very strong contingent of ladies also. Some of them are principal, that mission person. And then you will also see here that it will come up there or something has to be done. Okay, so this is nothing, this is our picture, okay, Mars picture and something like that. I am very happy that other one is coming. Now you see this, and I will just sit down for a while, few minutes. Okay, this particular is that what are the problems when you want to go to Mars, okay, because you need lot of power. Okay, and they have, with these things, they have made a 800 watts kind of power just from the solar. It's a big, huge thing. And again, these things takes on weight. And then they were trying for that, testing that. And I think, and then See, this thing is needed. Its importance is that when you are going to moon, sun is very close to you. When you are going to Mars, it is 3 times down, so it is 3 squares, something like factor of 10 down in energy it received. And from that you have to get the, this power system done. And so, and you need 800 watts there to run it. So that is why, certain things are much, much bigger and bolder than what was before. And the next one, even without the music, you can enjoy it, because it is just, I think this is, and you see, these are the pictures taken by Indian mission on the Mars surface, and they look quite good. But now I will show you what is really good. This is also Mars, taken by US missions. Okay, now you don't have to tell that there is flow and movement and something like that. And why I am showing you this, this was studied by one of the Indian PhD student in US, and he was first to show that something is happening. You can see these tricks, and then after 2 years or so, yes, it is confirmed also, and came out in a good paper also in Science or somewhere. And then, but you see, we are here and they are there. So in technology, is not very easy to compete with others. But on ideas and some particular things to do, I think we can still do it. Okay, now you see, these are also taken by our mission. Okay, Mars surface. So things can be done, but it is not. And this is what I was telling, that since we have gone all the way, we can study something and which is new and different. Evening time exosphere of Mars. Okay, this is not done earlier. And same way, observation of suprathermal argon ions and something like that. Because you are not just orbiting here, you are taking a large round, and so it can do it better. Okay, now I come to Chandrayaan 2. Okay, Chandrayaan 2, we wanted to send everything, lander, rover, and all done by ourselves. So this is the general configuration of Chandrayaan 2. And now, you see, this is how it will go. It is same standard technique, but we have to follow. The most important thing is that lander. Can we put a lander properly up there? So they have done lot of calculations. I don't know what those are, but they say after doing all this calculation, finally, you see here, if you see that vertical velocity is 1.8 meter per second, horizontal is 186 meter per second, then it comes 8.5, 121, 8.3, 0 meter per second here vertical, and then 0, 0 and landed. So again, I think they have done I presume they have done a good job, and I have faith in them. I think we are going to land well. And these are all the instruments. This time everything is done in India, is by India, for India, of India, whatever you call it. And because we don't need anybody else, because now one thing has happened in between. Now we get lot of, what earlier you can call banned item also from both US, Europe and Japan, because we are no longer in some list they make, we are no longer in the list. So we get lot of advanced, technology and based instrument. So we will have a X-ray monitor. Then this is for X-ray monitoring, the Chandrayaan 2, whatever you are showing there. This is a dual frequencies that our radar to look for water, and not a single dual frequency, so that you can, from the difference also something can be told. And then this is a imaging infrared spectrometer. It goes from 0.8 to 5 microns. We don't have to borrow big or do from others, so we can self-sufficient. Earlier we could go only up to 0.8 micron. And then this time mapping camera, we are very good at it. And then neutral mass spectrometer, okay, study of exosphere of Mars. So moon again properly. If we can detect something there, still we are not been able to detect anything. This is the laser induced broke down spectroscopy, and this will be on the rover. So on the rover, this is one of the instrument. Then another instrument is alpha particle X-ray spectrometry, because it will go around, it will sniff the surface. So you have the detector there, it will see something, you have a beam also that will hit it. It may be X-ray, it can be something else also, infrared, and then something will come up and that will be sensed by the detector. So then we have lander. Even though it is landing, we are trying to put as many payloads as possible. This includes thermal conductivity. You see, after landing, something will push below about 10 centimeter or so to see the thermal conductivity and the gradient. And then dust analyzer, that is also important, because if we go sometime there will be problem. And the levitation of lunar dust. And we have, I think we should have a seismometer also. Yes, seismometer, MEM sensor. These are very small, activities done by NGRI and some other people, okay, together. So all this instrument will be there. Where do we want to land? This was done along with the Russian friends when we were planning. We have to go near the poles, because we wanted to, again, water is one of the theme. Other things you can go and rotate, but we wanted to land there if possible. And then there are 3 sites. It is on the northern pole, southern pole. What you need is 20 kilometer in length, 10 kilometer in width. That is a safety zone. And then you will try to land at these spots within these zones. Okay, that is what is the challenge. Okay, and then power, sunlight, anyway, okay, that is all right. And I think I will not go to many more things. Already I have taken, more than an hour? 1 hour, okay. So I will try to stop, but let me see if I have anything interesting which I do. So advanced exploration of the outer solar system, we have to think. If you think 20 years from now, we should be there. And our main problem to go out is resource. We don't have fuel. Because sun is out, sun cannot supply it. All other people, they have their nuclear reactor. Only this big, thermoelectric nuclear reactor. So if BRC someday makes it, it will be good for us. And but other countries, nobody will give you. Everybody has it. And Japan, even today, they will not go nuclear. And so they take 6 years to go, 6 years to come back. They go by solar, and some they have something else also, but they generate their own energy. They have gone and come back also. One mission took them 12 years. They have gone to a comet, took a little piece, came back to Earth again. So they have done that kind of stuff also. But I think we should be able to do an ion propulsion is what Europe prefers, but it is very slow. Ion propulsion is very slow, and that maybe also we can, but most important, human resource development, academic and technical. So I like to, whenever somebody calls and I see a lot of young faces, I say that some of you should just sometimes don't tread the old path or something like that. Try to do something different. It's a risk is always involved. No risk, no risk, no gain. There is a old saying we were told. I don't know if it is right or wrong. But I would like some of you, it is not necessary that we have to make this instrument. I am not coming here for that. There are people who are needed to think what new can be done on Moon, Mars, or even if you go to Venus, and what we need to do that. Okay, because those ideas are very important. And then when you say, I want to find this on, say, Mars, it should not be just like, you want to find it because you think because of these, that, 5 different things, it will be useful to look at Mars and we may get some new information. If you do not get, there is nothing wrong. Same old story. I mean, that doesn't mean we have failed. We tried hard, but we could not get it. But we should try something new and different. Because that is why in Chandrayaan we went out, because when we realized we cannot make the instrument, it cannot be a world-class stuff. So I was trying to find out where we are. So I think Chandrayaan mission, you see that picture, that is a black and white picture of the whole Earth on the left-hand side. By the time of Chandrayaan 2, we can take color picture. That is our own Earth from close by. I think India is there somewhere. This is India here. So so these are good things, and I think we should let us try to. This is another problem. I think when we are working on other planets, we are trying to kill our own planet. So whenever I come here, I think please don't mind. I think the younger group is the one of the, I will call the reason for killing. I mean, you don't worry when you throw out something. I mean, so many things has come to in our time we don't have anything to throw. Okay, there's nothing much to throw. We eat in the home, go to school, come back, and there is no paper, no this, nothing. Now everything comes in packets and whatnot. and everything is throwing. And of course, we call it what we call Swachhata Abhijan or something. You see, I don't believe in government-sponsored things. I think we have to do it ourselves if we can. Government doesn't have to tell us what we should do. Then we will not do even what they want us to do. We should do it ourselves. We should try to do it sometime. That will be nice. And thank you for your kind attention. And I only want to tell that we are not the only planetary system. Now we have found more than 300 planetary system. Since I have called more than an hour, I will not talk about it. And only thing, this is something very funny. Not a single of this planetary system look like our planetary system. Not a single. So we can say we are unique. Or we can say we are an aberration. Choice is ours. So we can think whichever you want. But that is also a very exciting field. And in PRL now we can detect exoplanet from our telescope, because one fellow, sometimes you need some person who are little eccentric, but once you put them that you have to do it, I mean, then you should not talk to them and criticize, and give him time, and he has done it. And now we are at par with others on detecting exosolar system. And again, none of them look like, everything is very close to the central sun. I don't know why. We are spread out, they are not. And then there are other missions also. Kepler takes pictures. We do it by oscillation. You see, if like Jupiter, sun is here and Jupiter is rotating around it. When Jupiter is this sun gets pulled. When it comes here, it gets pulled. So it oscillates. Okay, this oscillation can be measured if you have very perfect instrument. And at PRL we have one now. In the whole globe there is about 6 or 7 which are agreed upon that their data is good. So we are happy about it. But I think I have talked enough about planets. Let us not go to exosolar system. Let us be happy with the solar system as long as we live. And I think if we don't do any stupid things to our own mother planet, or mother earth we call, right? So see, actually mothers are most generous and they suffer also maximum, because fathers generally run away. I mean, that even if you have problems, say kids have problem, we generally want to be So I think we should save our planet, and everybody should take a lot of part. But I think all young girls, ladies, anybody at any age, we can always try to see what we should not do for the next 30 generation of our mankind. At least 30 generation we should think of. That is not much. Only 13 to 900 years. Nothing. Very little time. Thank you all.
So it was indeed an intellectually stimulating lecture. And just add to your own bits of humor. So I realized that, as you said, Venus is so difficult to handle and it doesn't let anybody go close, so then less people get burned. So precisely I today got an idea why Venus is associated with feminine beauty. Now this house is open for a few questions.
If you have any question you can ask. Even if I have not talked something about something else. Yes.
That was a great talk, very informative, very motivating. So what I would like to know, that's about discovery of hydroxyl ions on the moon. And what's your opinion, whether that's indigenous to the moon or has that been inherited from other sources?
No, it is, because?
Yeah, because if you want to consider the evolution of the moon, right, that's very important over there, that if water was present, then how a hydrous moon would have evolved would have been very different to our current understanding where we consider.
Yeah. I can tell you, you see, I think I told you now, I got tired of telling that we are seeing water molecules. Okay? So if you think of, there is no water to really contaminate the moon or moon to do anything, we don't have to change our, but if water is there, it is a resource. That is our next destination, next home. So we don't stay on the surface, we'll go underground. If you go look at NASA, they are doing lot of stuff. So we'll go underground, but we need resource. And water is one of the most valuable resource. So if you can extract it, so we have to live near the polar region of the moon. So it is most as a resource, and I think it is very useful to go for it.
But based on the current information of the data that we have, is there any way to find out polar missions or not, that whether the water that we are discovering now that's indigenous to the moon, or whether those signals or those molecules were inherited from other sources.
No, there is no other source. Because you see, even here, only sunlight is there.
But implanted by the solar window.
No, that's what I'm saying. You are absolutely right. Source is sun. Okay, solar wind is coming. Okay, so H is coming. O is in the rock. So it has become OH, and if another O joined it, it has become another H come and hit it, is H2O. I told you that there are 3 papers written in 70s and 80s where they describe all the details what can take place, and that is why I thought that we should try to do it without telling anyone.
I thought that would do animal in situ experiments to actually drill in a bit in the lunar regolith and see.
Yeah, of course. No, regolith, no. It will evidently now I am telling you, any drilling and other activities will be in the lunar poles. Because it's sunlight also it sees little more than others, but we may for 8 days it gets sun. Okay, so there are quite a few things why polar region is a good thing if you want to ever go there. Okay. Yes, sir.
I got just one comment and one question related. Comment is that it's not directly related with the Chandrayaan or Mangalyaan, but one phenomenon which is topographic perception, false topographic perception phenomena, which we earlier identified on the satellite images of surface of Earth. The same phenomena we have also identified on the surface of Moon as well as on the Mars.
Yeah.
So this is just
It is there.
Yeah.
It is there. It's there.
Now the point related to that. During your presentation, you said that water is found in the shadow areas.
Shadow means where sun, where sun never looks at. Yeah.
So why?
No. You see, if you, it's like that. It is not shadow area. I should not have said that. You can say you can see it only in holes, like craters. Okay. Not in the, because crater is already below there. When it goes and hits, it is so cold that even the molecule it gets stuck there. Then it has to just do a little game with others, and then it can become. And then it is a very slow process. I mean, that's why I am saying that everyone said we found water on Moon. I mean, I say I will be happy if we have found OH and H2O sticking on the surface of the Moon. Sticking on the surface of the Moon.
One more point which I want to bring here. And regarding Mars, you said that there is no evidence of any water. But
no, there is evidence.
But it's a liquid.
Huh?
And
or no.
Liquid.
Yeah, some
liquid, not real ether. Because it is manifested through fluvial landforms.
Yes.
Beautiful fluvial.
And it will.
Which you can see on the surface.
Yeah. Fluvial, everybody, agrees, but water and where and how much, nobody agrees so far.
Yeah, most of these are there, but except glacial landforms.
Yeah.
All landforms are present on the surface.
Yes. I agree.
Piece of inquiry. Has anybody NMR probe?
No, not because you see, to make a miniaturized NMR will be very difficult. You are talking about magnetic resonance, right? Yeah. So I think I don't think India will do it in this in next decade. But if there is an idea that if we do NMR, we may hit this. Okay, because as of now we can only land on Moon. Okay, we cannot land on anything else with our present capability.
I'm not talking about India's.
But other people, and to be very frank, I feel if you want to look for something with NMR, and it will also depend what you are trying to look for. Okay, so but in principle, NMR is a good thing to check certain things. But as far as India is concerned, we are far away from it. Okay, yes, at least some ladies' voice also.
Good evening, sir. I have 2 queries. The first one is, what is the scenario of manned missions to space as far as ISRO is concerned? And the next one is, given the launch of IRSS satellite, so till what time or when we can have access to the benefits of IRNSS?
See, the second question you have to direct to ISRO headquarters, but I can give you a name also, because something even I made it a point that in Munis they cannot have the data. Data should be in our control. Because what happened, they are very worried. I know something, that whether you are getting what you call verified data or not. I mean, there is something, their term they use, okay, first layer, second layer, third layer. So unless you have a strong science problem which you can put out, and because of this I need this or something like that, then you may get some high end, whatever support you are asking. Now while I am telling this, I forgot what was your other question. First one.
The other one is what is the scenario of manned missions? When can
Man mission. Please, we are having hard time even lifting the rockets. So man mission, first thing you have to make sure that you have to make the man safe, right? So already some preliminary activities are there. We have something, one has gone up and come back without getting burned. We couldn't get back in the same place where we wanted. So now if we send somebody up, if he survives, he will come back properly to the point where we want him to come back. But we are yet to think how to make him survive. During that point, we need lot of things to do before we can do it. Man mission is, maybe you will see it. You may see it. Not us. Not us. You may see it someday.
I hope so. Thank you.
Okay, thank you.
Actually, she should demand women mission rather than men mission.
You see, once man mission goes, I can tell you one thing for sure. Like I was telling you, there are several chief of missions which are all ladies in ISRO. So I think they will come. You will find more ladies maybe handling missions than us. Okay, man. Okay. Anybody else? No?
So if there are no further questions, let's give a huge round of applause.
Thank you.
I'll now request Professor D.P. Srivastava to please come up stage, present a souvenir to the speaker and also offer a vote of thanks.
Professor Goswami, your erudite and lucid lecture has truly inspired the audience. It has ignited the young and not so young minds alike. Listening your lecture convinced us, and we feel that the students, research scholars, and colleagues working with you are most lucky. For taking us through a journey that is straight from fishing hamlet through Mars and moons to beyond, this audience ought to be most grateful to you. I know I am. May I now request you to give Professor Goswami such an applause that it goes loud enough to bring him back to this temple of Goddess Saraswati, the IIT Roorkee. Ladies and gentlemen, if the lecture was engrossing, the audience was also most delightful, curious, and alert. They too certainly deserve a big thanks from you. Let us also thank convener of this event, Dr. Anil Gauri Shetty, student volunteers of the Institute Lecture Series, the photographic section of Hobbies Club, Physics Department for hosting us, the state management team, and its media persons, if any. My colleague, Dr. Ajanta Goswami of Department of Earth Sciences deserves a special thank for facilitating Professor J.N.Goswami's visit to IIT Roorkee.